Hello and welcome to Maths with Mr Amison. In this video we're going to be practicing how to use frequency trees to help us solve probability problems that are a bit more complicated. If you need to recap this topic, then please watch this video here or follow the link in the description below. I'm going to show you an example, then I'm going to talk through it, and then I'm going to give you some time to copy down the example and have a go at the question on the right. Follow through and pause whenever you need to. So in this question here, I started off with 30 students in total, and these were split into two categories, male and female. 14 were male students, therefore the other 16 were female. If 8 male students had blonde hair, that means this number here would have to be 8. And because there are 14 males in total, the number of males that did not have blonde hair would have to be 6, because 8 plus 6 is 14. For females, it says 9 female students had blonde hair. So if we have 9 here, then there are 16 in total. So 9 plus 7 is 16, or 16 take away 9 is 7. So 7 did not have blonde hair. If I pick one student at random, you'll probably see they are male and don't have blonde hair. That's this box here, because if we go male then not blonde, then we have 6. So 6 out of the 30 students were male without blonde hair, so the probability is 6 out of 30. Alright, take time to copy down that example, and once you're done, have a go at the question on the right. You can pause now. Alright, so now you've had a chance to have a go. If we have 20 students surveyed about whether they have pets, that means we have 20 students in total, right here. If there were 12 female students, that means we split 20 into male and female. So we have 12 female students, and therefore we have 8 male students. Because this 20, these two branches need to add up to that 20. If 6 male students had a pet, well, that means that we can split this off into pet and no pet. So 6 male students had a pet, therefore to make up to 8 we need 2 male students without a pet. For females, if there were 12 female students, 7 of them had a pet. We can put the 7 in there, which means that we need 5 without a pet. So if I pick one student at random, what's the probability they are female and don't have a pet? Well, female is this branch, no pet is this branch, so this is where we're interested. So that's 5 in total out of the 20 students, so the probability is 5/20. Alright, so 4 questions for you to try. Fill in the missing gaps in the frequency trees, and then see if you can answer the question at the bottom. So here are the answers to these questions, these problems. Question 1, 300 students in year 9, so this is 300 in total. I'm not worrying about the box here, but we have 80 males taking geography. So if we have males and takes geography, we have 80. If we have females that do not take geography, we have females and do not take geography being 60. Now this was given in the question, which means the total number of females was 160. If there are 300 students in year 9, that means the total number of males is 140. And because we already know that we have 80 here, it means this has to be 60, and therefore we're done. No probability is being asked for there. Question 2, 120 students in year 7, 70 have a pet. So out of 120 total, 70 have a pet, which means that we have 50 without a pet. Now, 30 males have a pet, so out of those that have a pet, 30 of them are male, which means 40 are female. 40 females do not have a pet, so if they do not have a pet, then we have 40 of them being female, which means 10 of them are male. How many males are there with no pet? Well, we've just answered that. It is therefore 10. Question 3 is the first one where we have to find a probability. Question 3, 250 students in total in year 10, 120 are female, which leaves 130 to be male. Alright, and then out of those, we can split those into takes history or does not take history. 80 females take history, so out of the females, 80 of them take history, which means 40 do not, because they add up to 120. If 60 males do not take history, so 130 males, 60 do not take history, that leaves us with 70 that do. What is the probability that a student did not take history? Now, if they did not take history, that is the 60 and the 40, both the males and the females. So that's 100 in total out of 250 students in total. So we have 100 over 250 as our probability. Question 4 is really quite tricky. If 48 students passed the maths test, we could have split this into male and female first and then pass, fail, pass, fail. That's a bit more tricky. We can split to pass, fail first. It makes it a bit easier. If we do so, then we can put the 48 here straight away. If we have 48 there and then 12 female students failed, or we could put the 12 in here, and then 22 male students passed, so we have 22 here, which means that this has to be 26 because they need to add up to the 48. Then 68 students took the test in total. That information comes a bit later in this question. So if 68 took the test in total, that means the pass and fail must add up to 68, so the fail number is 20, and therefore the male number has to be 8 because these would then have to add up to 20. If there are, looking at the male students only, male students in total, there's 22 here and 8 here, so that's 30 male students in total. What's the probability a male student failed the test? Well, that's 8 males failed out of 30 males altogether. Therefore, the probability that a male student failed is 8 over 30. Thanks for watching. Hope you found this useful. Speak to you soon.